So lesson 17 is all about oscillation. It's all about oscillation. So first, we have to get our understanding of oscillation very clear. Now, oscillation is very important when you come to waves. Why? Because in the very first lesson I've already told you, no waves can be generated without an oscillation. And oscillation can also be perceived as a disturbance. You must have a disturbance, you must have an oscillation, only then waves will be generated. So it is only proper we learn what a oscillation is. So oscillation is basically a system or a particle. A system or particle is at equilibrium point. So let's say this is a particle. This particle is at an equilibrium point, which I'm going to indicate that with a line. So this is the line of equilibrium. So I'm just going to put it as equilibrium. All right. So that's equilibrium. Okay. So that's an equilibrium point. Okay. So this particle, all right, can this part before a system can oscillate, we have to cause a displacement. We have to cause a displacement of that particle from its equilibrium point. So you have to take this particle and you got to displace it here, and then you got to release. You got to release. So when you release, there must be what we call a restoring force. A restoring force to bring the particle back to the equilibrium point in order to cause it to oscillate. Now, in this diagram, you cannot see. So now I'm going to add another component. So another component will be, let's say, okay, let's say this is I put it as a spring. Okay. Or rather, I'll change it the other way around. I'll put it this way. Okay. That's the particle, same thing. So that's the equilibrium point. So I've added the spring component. So what you are doing is you have pushed this particle up, let's say to this point, causing the spring to compress. So the spring is compressed, and then you release. Alternatively, you can put it down, causing the spring to be stretched, and you release. So you can either compress it and release, stretch, release. Either way, you must cause a displacement. So I've just caused a displacement. When I release, the restoring force, that means the force in the spring, the compression force will push the particle back to its equilibrium point. The objective of the compression force is to bring this particle back to the equilibrium point. Why? Remember, equilibrium point is the most stable point in any oscillation. All right? How can I see it? Let's say this spring eventually does not oscillate. It comes to a stop. So my question to you is, where will it stop? It will stop at that point. Why does it stop at that point? Because it's the stable point. So what does that show? Equilibrium point is the most stable point. This type of analysis is needed. So as I go along, I'll plug you in with a lot of knowledge and concepts. Please slowly grasp that. So that is that. So the compression force in the spring pushes this particle to that point. But upon reaching that point, will the particle stop? The point is it will not stop. Why? You can view this in two ways. One of the ways you can see is because don't ever forget the particle as inertia. So when the particle has inertia, and of course by it moving down, and the compression force has pushed the particle down, it gave the particle a velocity, gave the particle a speed. So at this point, the particle has speed, or you can see it as inertia. So the inertia of the particle will not allow it to stop there, because you should know what's the definition of inertia. Or you can see it from the momentum point of view. Whatever way you see it, the inertia of the particle or the momentum of the particle will cause it to move here and not stop. So as it moves here and not stop here, as it moves here, the spring gets stretched. Therefore, the restoring force is built up again. Here, very high restoring force, which is the compression. Upon reaching here, the restoring force becomes 0, but the particle as inertia, momentum, that will not allow the particle to stop. The particle will keep on moving this way, and the particle moves this way. Restoring force is again developed in the spring in the form of stretching force. So let's say somewhere it reaches here. All right, somewhere it reaches here. So I'm going to indicate that. All right, the speed of the particles becomes 0. When the speed of the particle becomes 0, and now the particle stops. Where does it stop? It stops here. So now the restoring force is maximum. So the restoring force can act. Earlier, the restoring force gets built up, but not enough to pull the particle back. Not enough to pull the particle back because a particle still has kinetic energy. So cannot overcome it. All right, cannot overcome its inertia. Year upon year, the restoring force is big enough to overcome its inertia and pulls it back. So when it pulls it back, it comes back here, restoring force is again 0. It has brought back to the equilibrium point. But yet again, the particle has acquired speed. And again, its inertia, or you can look at momentum and inertia, will not allow it to stop. And the particle will overshoot and move here. As the particle is moving here, restoring force again gets developed. That is the compression force. Upon reaching here, the speed of the particle becomes 0. The restoring force is huge enough, large enough to push it back to the equilibrium point, and the process gets repeated, and this causes the oscillation. So basically, for oscillation to occur, you need two components, the restoring force and the inertia, and it is the mutual reaction or interaction between the two that causes the oscillation. This is one way to look at it. Another way, of course, is to look at the energy point of view, which I'm not going to visit it here. All right? So this is just oscillation point. Now, this point and this point are what we call endpoint. So in an oscillation, of course, there are many points, but there are three most important points, which is very important, that is needed to describe and understand the oscillation. They are the two endpoints and the equilibrium point. Now, these are the 3 points which are very important in any oscillation. All right? Now, when the particle is here, that's the displacement. When the particle is here, that's the displacement. When the particle is here, that's the displacement. Now, the particle cannot go beyond the endpoint. Therefore, this becomes the maximum displacement. All right? And this maximum displacement comes with a terminology. All right? Now, this is what we call amplitude. So I've already introduced amplitude when dealing with waves, where we said amplitude is the maximum displacement measured from the equilibrium point. Again, if you look at it, all measurements, if you see, is all from the equilibrium point. Everything is measured from the equilibrium point as far as displacement is concerned, but the end point is a very unique point. What's so unique about the end point? That is where you achieve this. And therefore, amplitude is the displacement between the end point and the equilibrium point. Now, what about this? Is that the amplitude? Yes, there is also the amplitude. But since amplitude is a vector quantity, and if you are measuring, because it's a displacement, amplitude is displacement, which is a vector. So this would take a negative one. So by convention, we do not take negative displacement as the amplitude. We keep it to the positive. That is why I always refer this as the amplitude. But technically speaking, this magnitude is also the amplitude. All right, it's also the amplitude. This is what you call oscillation concepts are. So now we are ready to define oscillation. So what is oscillation? So oscillation is defined as a two and fro motion. All right. Oscillation is defined as a to and fro motion. You can take it as to, you can take that as fro. To and fro, to and fro, to and fro, to and fro about this point. So it's a to and fro motion about what point? Equilibrium point. So you must take that. All right. In your definition of oscillation, you must say that oscillation is a to and fro motion about the equilibrium point. Number two, does it occur irregularly or does it occur regularly? What does that mean? That means, does it take from year to year 1 second at one time, and then from year to year 2 seconds, and then the next moment from year to year is 4 seconds, and then from year to year is about 2.5 seconds? Is it like that? No. If the time taken from year to year is 1 second, from year to year will be 1 second, it will be again from year to year 1 second. Therefore, it is like more like a regular, all right, regular interval of time. So to that, we have a word attached to it. We call it periodic. So it occurs periodically over a regular time interval. This oscillation occurs over a regular time interval. This is what are the concepts of oscillation in our physics of study. So therefore, putting all that together, oscillation is defined as the periodic to and fro motion about a fixed equilibrium point.